The world of finance is changing rapidly, evolving in ways we never imagined before. A groundbreaking technology is emerging. It's called blockchain. Imagine a digital ledger that is both innovative and transformative. This ledger is shared across a vast network of computers, creating a decentralized system. It records transactions in a secure and transparent way, ensuring that every entry is verifiable and immutable. This is the essence of blockchain technology, a system that promises integrity and trust. Blockchain is a revolutionary technology poised to change the way we handle data and transactions. It has the potential to transform various industries from finance to healthcare, supply chain to real estate. It offers unparalleled transparency, robust security, and remarkable efficiency. By eliminating the need for intermediaries like banks, blockchain enables direct transactions between parties. The concept of blockchain is relatively new, yet it has already made significant impacts. It originated in 2008, marking the beginning of a new era in digital technology. It was created by an anonymous person or group known as Satoshi Nakamoto, whose identity remains a mystery. The idea was to create a decentralized digital currency, free from the control of any single entity. Blockchain is a complex technology, involving intricate algorithms and cryptographic techniques, but its basic principles are easy to understand. It's essentially a distributed database that anyone can access. It stores information in a secure and transparent way, making data tampering nearly impossible. It's the foundation of cryptocurrencies like Bitcoin, which have revolutionized the concept of money and transactions. In 2009, Bitcoin was born. It was the first cryptocurrency to use blockchain technology. Bitcoin was a revolutionary idea. It allowed people to exchange value directly. No banks or intermediaries were needed. Bitcoin is a digital currency. It exists only in the digital world. You can use it to buy goods and services. You can also trade it on cryptocurrency exchanges. Bitcoin is decentralized. This means no single entity controls it. It's governed by a network of computers distributed worldwide. This makes it resistant to censorship and manipulation. The creation of Bitcoin marked a significant milestone. It demonstrated the power of blockchain technology. It paved the way for the development of other cryptocurrencies and blockchain applications. Bitcoin and blockchain are two sides of the same coin. They are inextricably linked. Blockchain is the technology that underpins Bitcoin. Bitcoin is the most famous application of blockchain. Think of blockchain as the operating system. Bitcoin is one of the applications running on it. Just like you can have multiple applications on your phone, you can have multiple cryptocurrencies on a blockchain. Bitcoin transactions are recorded on the blockchain. These transactions are grouped into blocks. These blocks are linked together in chronological order. This forms a chain of blocks, hence the name blockchain. The blockchain is a public ledger. Anyone can view the transactions recorded on it. However, the identities of the parties involved are kept anonymous. This ensures privacy while maintaining transparency. Transactions are the heart of the Bitcoin network. They represent the transfer of value from one user to another. When you send Bitcoin to someone, you initiate a transaction. Each transaction contains essential information. This includes the sender's address, the recipient's address, and the amount of Bitcoin being sent. This information is broadcast to the network of Bitcoin nodes. These nodes are computers running the Bitcoin software. They verify the transactions and add them to the blockchain. This process ensures the integrity and security of the network. Once a transaction is added to the blockchain, it becomes permanent and irreversible. This immutability is one of the key features of blockchain technology. Section 5. Delving into the block. A block is a container for Bitcoin transactions. It's like a page in a ledger. Each block can hold a certain number of transactions. The size of a block is limited. When a block is full, it's added to the blockchain. A new block is then created to store new transactions. This process continues indefinitely. Each block contains a header and a body. The header contains metadata about the block. This includes the block version, the previous block hash, and the timestamp. The body contains the list of transactions. The block header plays a crucial role in securing the blockchain. It's used to create a unique fingerprint for the block. This fingerprint is called a hash. Section 6. The miners' digital gold diggers. Miners are responsible for adding new blocks to the blockchain. They compete to solve complex mathematical problems. The first miner to solve the problem gets to add the next block. This process is called mining. It's computationally intensive and requires specialized hardware. Miners are rewarded with Bitcoin for their efforts. Mining serves two main purposes. First, it secures the network. Second, it introduces new Bitcoins into circulation. The reward for mining decreases over time. The difficulty of mining adjusts automatically. This ensures that blocks are added to the blockchain at a consistent rate. This rate is approximately 1 block every 10 minutes. Section 7. Proof of Work, Securing the Network. In this section, we will delve into the intricate mechanisms that ensure the security and integrity of the Bitcoin network. Is the consensus mechanism used by Bitcoin. It is a fundamental chain system. It ensures that all nodes on the network agree on the same version of the blockchain. This consensus is crucial for maintaining a single unified ledger. This prevents double spending is when the same Bitcoin is spent more than once, which POW effectively prevents. POW requires miners to expend computational power to solve mathematical problems. These resources to solve. The first miner to find the solution proves that they have done the work. This process is competitive, and only the fastest miner gets rewarded. This work is represented by the hash of the block header. The hash is a unique digital fingerprint of the block. The hash must meet certain criteria. The solution is valid and accepted by the network. The miner wins the block reward. This reward incentivizes miners to continue securing the network. POW makes it extremely difficult for attackers to manipulate the blockchain. The computational current. They would need to control a majority of the network's computing power. This is an enormous amount of resources, making such attacks impractical. This is known as a 51% attack. If successful, it would allow the attacker to alter the blockchain, but the immense difficulty makes it highly unlikely. Section 8. Cryptographic hashing, ensuring data integrity. Cryptographic hashing is a fundamental concept in blockchain technology. It plays a crucial role in maintaining the security and reliability of the data stored within the blockchain. It ensures the integrity of the data stored on the blockchain by providing a unique digital fingerprint for each piece of data. A hash function takes an input, which can be any size, and produces a fixed size output, known as a hash. The output, or hash, is a unique representation of the input data. It's unique to the input data, meaning no two different inputs will produce the same hash. Even a small change in the input will result in a completely different hash, making it easy to detect any alterations. This property makes hashing ideal for detecting data tampering, ensuring that any unauthorized changes are immediately noticeable. Blockchain uses a specific hash function called SHA-256. It's a one-way function, meaning it's easy to compute the hash from the input but impossible to reverse the process. This means that it's easy to calculate the hash of an input but impossible to reverse the process to find the original input. Hashing is used extensively in blockchain technology to ensure data integrity and security. It's used to create block hashes, transaction IDs, and digital signatures, all of which are essential for the blockchain's functionality. It ensures that the data on the blockchain remains tamper-proof, providing a secure and reliable system for digital transactions and data storage. Section 9. Consensus mechanisms. The power of agreement. Consensus mechanisms are the heart of any blockchain. They ensure that all nodes on the network agree on the same state of the ledger. This is crucial for the integrity and security of the blockchain. Proof of work is just one type of consensus mechanism. Other mechanisms include proof of stake, delegated proof of stake, and practical Byzantine fault tolerance. Each consensus mechanism has its own advantages and disadvantages. Proof of work is energy-intensive but highly secure. Proof of stake is more energy-efficient but can lead to centralization. The choice of consensus mechanism depends on the specific requirements of the blockchain. Factors to consider include security, scalability, and energy consumption. Section 10. Blockchain beyond Bitcoin. Blockchain technology has the potential to revolutionize various industries. It's not just limited to cryptocurrencies like Bitcoin. It can be used for supply chain management, voting systems, and digital identity. In supply chain management, Blockchain can track the movement of goods from origin to destination. This improves transparency and accountability throughout the supply chain. In voting systems, blockchain can create a secure and transparent platform for casting and counting votes. This can help prevent voter fraud and ensure the integrity of elections. In digital identity, blockchain can provide a secure and decentralized way to manage digital identities. This can reduce identity theft and streamline online interactions. Section 11. The future of blockchain. A world of possibilities. The future of blockchain is bright. As the technology matures, we can expect to see wider adoption across various industries. Blockchain has the potential to create new business models and disrupt existing ones. Governments and organizations around the world are exploring the potential of blockchain. They are investing in research and development to harness its transformative power. Blockchain is still in its early stages of development. There are challenges to overcome, such as scalability, regulation, and public awareness. However, the potential benefits are too significant to ignore. Blockchain technology has the power to create a more transparent, secure, and efficient world. It's a paradigm shift that will continue to shape the future of finance and beyond.